Ladies and gentlemen, dear students, welcome to Eco Astronomy Astro Week. Actually, we are glad to have with us today one of the most devoted executive directors, Mr. James Burk of the Mars Society Mars Technology Institute. Mr. Burke is very well known for his high quality expertise for leading the staff of the Mars Technology Institution, not to mention his brilliant management of Mars analog research project conducted both in US and Canada. And for sure, his devotion to astrospace and astronomy and Mars exploration research are absolutely inspiring. Now, for this special Astro Week, Mr. Burke will take us in a very unique journey through his lecture to discover the exploration and settlements of Mars. Mr. Burke, the floor is yours. You can get started.
Thank you so much, Majda. It's a pleasure to be here today. And I'm going to talk to you about the experience I had recently at our Mars Desert Research Station in Utah. There you can see me gearing up and getting ready to put on my spacesuit and go outside on a simulated extravehicular activity, or EVA, with my crew. It was a fantastic experience, and it's an experience that it's open to everyone around the world to come stay at our research station and be part of a crew. And so I'd love to talk more about that with you all today. Can you see my slides okay? Yeah, okay, great.
Positive.
Okay, awesome. So this is not a computer AI artwork. This is not like a painting. This is actually a photograph of where we are out in the Utah desert. And it's called the Mars Desert Research Station. This will be our 22nd field season there. So we've been doing this for 22 years now. We've had over 2,000 crew members and 300 crews stay at the station. Each one has been for 2 weeks with roughly 6 to 8 people. And four of those 2,000 have become astronauts. So by going through our program, you apparently have a 1 in 500 chance of becoming an astronaut right now. And we're really excited about those four astronauts. There's been a couple that more recently were able to go to space, Kelly Girardi and Shauna Pandya on the Blue Origin commercial space flights and Virgin Galactic space flights. And then Jessica Watkins stayed on the space station, ISS, and she's part of the NASA astronaut corps. And she actually is in line to be one of the Artemis astronauts. So she might be the first woman to walk on the moon. And she went through our program in 2005. So very exciting. I'm very honored to be part of this program and be part of the Mars Society. Now, the Mars Society, we do a lot of different things. The Mars Desert Research Station is just one of our projects. We also have another station up in the Arctic that Majda mentioned called Flashline, and we recently reactivated that station last year. So we had not been up there for a while. We had not been up there for about 7 years. It's very far north in the Arctic Circle on Devon Island. Devon Island is an island about the size of Ireland, and it has an impact crater. And there's only a few impact craters that are that well preserved in the whole world. So it's a very interesting scientific target to go to. NASA had been going up there for many years before us. And so we've now we've actually sent 16 crews. I need to update this slide. We've sent crew 16 just this past year. And so we're now having an annual cadence to go every year. We're currently planning another field season next summer, so next July and August of next year. And again, this is an opportunity open to anyone around the world. That one's a little expensive. It's about $20,000 to be on the crew for the Arctic expedition. But any scientist can do that. Really anyone, anyone that has that is able to generate that level of funding for their projects or find that from their own support network is able to go on that mission. In Utah, it's a little cheaper. It's about $2,000 for a student to come for 2 weeks. It's still a lot of money for people, but it's very affordable also for a lot of folks. And we are working with others to create more of these stations. There's actually other stations like this around the world. These were the first two ever that were created by the Mars Society, but other organizations and countries have also created their own at this point. We are working with teams in Australia and Mongolia to begin projects like this to build a habitat. And what you see is basically, there's a two-story building that comprises both of the Arctic and the desert research stations. That would be a landed spacecraft that you landed with on Earth or from Earth, landed on Mars, and that would be your home while you were there on Mars. In Utah, we have a couple other buildings as well, such as the Science Dome, the greenhouse, and an observatory. But a minimum station would be something where you could have a crew of 6 to 8 people sleep and have room for their gear so that they can put on spacesuits and go outside, and then maybe a little bit of a science lab. So the minimum research station for something like this you could make could be something as simple as 3 tents or 3 yurts that you set up. And so we've been advising the Mongolians, you guys don't need to build a whole fancy station like we did in Utah to do this. You just set up 3 yurts and you get some gear and just use your imagination to simulate a Mars mission. So anyway, this field is open to anyone to work in, and we're excited to work with partners around the world to expand these network of bases. The Mars Society also has a couple other programs we do that are global. We have a University Rover Challenge. We hold that in Utah, and folks from around the world come from different universities. They form teams. They build their own Mars rover, many different designs, and they bring those to Utah to compete. There's also a rover challenge in India and one in Europe as well that are similar, that are part of our network. So kind of a network of those worldwide. We have an ambassador program. We have over 50 ambassadors now. So Aravinda is one of our ambassadors. And those folks are able to go talk in their communities about sending humans to Mars and elevating public awareness about Mars overall. And then we have other educational programs that are global in scope, such as our high school engineering challenge that happens every summer. So, it's a fantastic experience to go on one of these missions. Here's 2 of our recent crews that went up to the Arctic, to our station there. To go to the Arctic, we actually have to charter a plane. So pay for our own plane, and it's all the gasoline it's going to use to get to the Arctic base. So it can be quite expensive for that mission. But once they're there, they're able to conduct all types of different research. They can study the environment. They can study the effects of climate change in that pristine environment up in the Arctic. They can analyze the impact crater, and the geologic and extremophile research around that impact has been a target of research for many for a long time. But we also just practice the human factors challenges of operating on Mars. How do you have a group of 6 or 8 people working together well in a harsh, extreme environment that's isolated? it presents a lot of unique challenges. So we've been up in the Arctic for also about over 20 years now, 16 missions over 21, 22 years, and we found that it is a great place for science. I mentioned the impact crater is one of the main features of that environment. It's a pristine impact crater. It was a direct hit on the Earth by an asteroid, not an oblique hit. So it's a perfectly shaped impact crater. And there were ocean fossils there as well as algae because, that area was not always up in the Arctic. The Earth shifted on its poles. And so, between the time that impact crater happened and now, it shifted to be up in the Arctic. So it's very well preserved, not a lot of erosion. There's also a lot of opportunities, we think, up there for radio astronomy because it's so quiet and there's not a lot of interference you would have for radio astronomy or visual astronomy for that matter. Both of our sites are excellent for visual astronomy. There's no light pollution. So those are it's a great place for science. It's challenging logistically and costly, but we've determined that if we can build a crew of 6 people every year that can each afford the seat for $20K, that can fund the mission in totality. And then down in Utah, this is our campus. You see some of the vehicles we use when we go outside on EVAs, we ride in those vehicles. The ones in the middle of the picture are 2-seat Polaris Ranger EVs. So we could take those about 4 or 5 kilometers away from the station. And I'll talk about that, but that was one of the more exciting aspects of my mission when I was there for 2 weeks last year, was getting to go on those long EVAs where we would go explore an area, go explore a canyon system or explore some lunar terrain using those vehicles. So for the Utah site in Hanksville, where the Mars Desert Research Station is, it is a very excellent geological analog to Mars. It looks like Mars. There's many different types of terrain present. I mean, it's just spectacular to be there. You have all these huge hills all around you. It feels like you're in a movie set, but it's a real place. And there's not only Mars-like terrain, there's even lunar terrain we have out there. But it's a harsh environment. Like not a lot of people look at these pictures and think it looks sunny and calm, but it gets pretty windy out there, and there is weather. There is sometimes rain and snow out there. When it rains, it gets extremely muddy. All that dirt gets all over everything. So we hate when it rains because it takes days to dry after a large amount of rain, but that only happens a couple times a year because it's the desert. Yes, because we've had so many crew members out there, we've been able to do some human factors experimentation, like some studies of how people work together, how different crews interrelate with each other. One of the biggest insights we found is that women do better at this field of work, of living in space. In general, women do better because in general, women communicate more than men. And when you have a problem in space, the last thing you want to do is charge off and do something to solve it. You want to talk about the problem with everyone and find a solution that works for everybody, because you're usually in a situation where you're on a crew and everyone is integral to the mission, and everyone has a job, and they often there's often differences of opinion of what to do to solve a problem, and so working those out is part of all this. And so in general, women do better because they communicate well. and they check in with each other more often. Now, obviously, there's examples of men really being excellent communicators, hopefully like myself, and there's examples of women that are not so great at communication. But in general, what we found is, women and do well at this. So that's a key that's a key insight that not a lot of people in the space community know, because it's been so male dominated. All the astronauts, from the U.S. came from the military in the early days. There weren't any women. And so, most people just assume that, the perfect astronaut is some test pilot that's real macho and a man's man. But actually, that's not the kind of person I would want on my crew on Mars. I'd want people that work well together. So, and I found that in this mission I did, it was just like that. We wanted to accomplish a lot in 2 weeks, and so it was key that we were able to communicate with each other. I'll mention there is a larger community we're part of, and we're working to start a journal where we can publish the research we do. We may announce that next year. It's kind of still in development. We're still trying to work out how we're going to do the journal exactly, but it is a project we want to do. And then we're a key participant in a program called the World's Biggest Analog, where we're going to have crews at each of the different research stations all at the same time around the world and do some coordinated activities. And then there's a whole standards body that has been set up for analogs that we're part of. So I'm going to talk now about the mission I was on. This was last year, and I was the commander. It was the first time I was the commander of a mission of 7, and most of the crew you could see there were women. It was 5 women and 2 men. We didn't really plan it that way. It just happened that way, that we would add crew members, and we were adding people that were part of the experiment set that we had, and a lot of those PIs happened to be women. But it was an excellent crew. I mean, we were a very high performing crew of 7, and I'll introduce you to all of them here. So there's me, the crew commander, and I was very excited. That middle picture, I was pointing to the map there. We were about to go on my favorite EVA of the mission, so I was pretty excited that day. My executive officer, the second in command, was Aline Ducati, who works for the European Space Agency. She's one of the key engineers on the Ariane 6 project to build a new rocket there in French Guiana, down in Kourou. And she had been on another analog mission called Amadi in Oman in 2018. She's part of the French Mars Society. And Cecile Renaud was our crew microbiologist and greenhab officer. And she's going to the university in Belgium right now to get her PhD. And one of the things that she did during our mission, which was very notable, was we grew tomato seeds in simulated Martian regolith. So nobody had ever done that at the station, and people actually told us it was impossible to do, and we did it. And the way we did it was we took the Martian regolith simulant, which has no nutrients at all in it. It's soil that's from the Mojave Desert in California in the US, and basically little rocky pebbles that are tiny. And we put in there compost from my kitchen, so kitchen scraps that were composted in a machine called a lomi. That provided the nutrients, and then the secret ingredient was spirulina algae, and that caused the plants to germinate because it acted as a biostimulant. So we were very proud of that. Still remain very proud of that. We talked about doing that before the mission, and then we did it during the mission, and to everyone's surprise, it worked. Julian is our crew engineer. He was a fantastic crew engineer. He was running around fixing things at the station and developing new things, writing code. He created a whole power system monitoring. He created a monitoring for our EVA using a Garmin devices so that we can track where we were on the map, which was a breakthrough. We didn't need to have the radios working when people were out far away from the station. We could see where they were on the map, and that was important for safety. And that was an innovation that has now made its way back into the program for all crews that we started on our mission. Chris was our crew journalist. She's an amazing artist and photojournalist, worked for National Geographic, but now she does museum art. And she took a lot of just extremely artistic photographs of both of us, the crew members, but also of the environment. And she's trying to get those into museums now. And so, but she also wrote reports every day. There was a journalist report that she wrote, and she tied in storytelling with whatever we were doing that day. And just fantastic crew reports like that. She's like the model crew journalist, I think. And then Erin Kennedy. Erin actually just gave a TED Talk in the last 2 months about our mission. And she built her own rover that she's working on there in the middle. Those two orange wheels are part of the rover. She designed a rover that is a wind-powered rover that you would drop on Mars, and it would go along the surface and try to find evidence of CO2 geysers, which have never been photographed. And she tested that out in the desert in Utah. She's 3D printed the entire robot, designed all the electronics, wrote all the code. She's a fantastic engineer, really impressive person. And but yeah, she just gave a TED Talk. We haven't seen the video yet of it, the recording of it yet, but I can't wait till that comes out because I heard it went really well. She was practicing for that TED Talk for a while. And then Audrey was our medical officer. She was a student at the University of Paris in pharmacology, and she brought 2 medical experiments where we were testing out new medical devices for cardiovascular health, and also a way to collect blood and urine samples using just paper cards so they could be shelf stable. So you wouldn't need all this different medical gear if you were going to have astronauts collect samples over time. The samples would fit in a very small space. You could actually see it there in that second picture on the table. It's a little card stack that the cards were put into. So it's a kind of innovative way to collect health data. So that was our crew, high performing crew. We all got along really well. And by the end of the 2 weeks, I felt like we could have lived on Mars for a long time. Like, we were doing really well at that. And we were living comfortably. We were cooking for each other. We were all getting along, and we were getting a lot of incredible work done. And this is a list of all the experiments we did. So I'll talk about the 3 that are in red, but there was a lot of stuff we did there. You know, each crew member had 1 or more experiments that they were working on. And we flew, we tested equipment out, we tested out new processes for health. We tested a rover. We monitored the power system. We did safety drills. Everybody got trained on different safety procedures. We did actual drills where people didn't know it was a drill and thought it was an emergency and had to react quickly. And everyone did fantastic with that. And then education and outreach videos, we made a bunch of those, and those were ran on ESA's network, got lots of views. So yeah, it was fantastic. But I'm going to talk about the EVA situational awareness a little bit more. So this is what Julian designed, a system where we had these small satellite devices that we carried around with us when we went out on EVA from the station. And on the map, we could track where everyone was in real time. So you can see on the far right, those red lines and white dots were crew members stopping and taking stopping and sending a message or taking a data point. And we, in real time, when we're back in the habitat wondering what people are doing, we could just see it on the map. And we could also communicate through the map to them if we needed to by sending them small text messages. So like I mentioned, this was a big breakthrough because normally we're relying on radios to talk to people. And because that terrain is so hilly, as a matter of fact, right north of the station, there's a huge landform. So as soon as you drive north on that road, you lose radio contact with the habitat right away. And you may get it back sporadically when you're up there north, but not often you don't. And often, if you're in the habitat as one of the people that's waiting for the crew to come back, it can get kind of nerve-wracking if you don't know how they're doing or where they are. You don't know if they've flipped a rover and gotten hurt, for example. So you're just waiting for them to call into the radio, usually, to say they're okay, they're coming back. Or even worse, like they come back late. You know, we usually have a time we're supposed to be back, and if they don't come back by that time, it's an automatic emergency search and rescue situation where you break sim and get in another rover without your spacesuit on and try to find them, make sure they're okay. So we never had to do that because we always had the situational awareness through this map. And so the way it worked is we used Garmin devices, but we were also testing a new method that used low-cost radios that cost about $30. They're called Meshtastic or LilyGo Echo devices. And I'm holding one up there, and you see another one on the bottom. But these work the same as the Garmin devices. They're little data relay devices. So if you each had one of them on your person, it would create a mesh network. And at this point, we now have some up on some of the taller hills. So we essentially have an ad hoc mesh network whenever people go out on EVA, and we can actually track where they go. All those lines you see are made up of individual data points of position information for 2 of the astronauts on our mission during an EVA. So now we have this system operational, and it's very low cost, and it works great. And we also could do things with it, like control a rover through that network. So you could have one of these devices on a rover and send commands to it through that data network. Maybe even send a picture back, although it would be a really low resolution picture, but it's possible to do that. So there's one of the devices up on top of a hill with a battery pack inside it and a bigger antenna. So I'm really proud of this project. This is something where we had this idea, we demonstrated it, and then now it's part of the program. So everyone benefits from that now. So another project I worked on is Mars VR, and this is a digital twin of our Utah station. So we put everything into virtual reality, as well as the training that we do, the crew training, how to put on a spacesuit, how to use some of the different facilities, how to grow a tomato plant in the greenhouse. All of that is in VR, and it's free. And we actually have multiple different applications. There's not only the ones that work on a headset, like the Oculus Quest, but there's a version that works on any mobile phone or device that you can use as well. So check it out. It's marsvr.com. We've been working on this project for about 7 years now. So So that lets anyone kind of understand what we do out there. And then this was that experiment I mentioned. There's the regolith we got from Martian Garden from the Mojave Desert. And the key ingredient was adding compost and spirulina algae to stimulate those small seeds to grow. And she's duplicating this experiment now in her PhD program in Belgium as part of her PhD. So this is the goal. This is what a Mars base would look like. This is the Mars Direct plan. So this is kind of what we are simulating is that this type of first landing on Mars, where you have the habitat land, maybe you have an inflatable greenhouse, and then to get home back to Earth, you have another vehicle that's fully fueled waiting for you. So now you can imagine that this painting was made in the 1990s. You can imagine now that that would be Starship there. Now we actually have hardware people are developing that is real for this. It's not a concept anymore. This is about to become reality. This is an example of a larger base. So maybe this is a 30-person base on Mars, where most of it's underground, but you have a dome, and then you have a little greenhouse there that's growing food. And you would need a lot of space to grow food for a large crew. That's one of the projects we're working on right now at the Mars Technology Institute, is to figure out what are the best ways to create food on Mars for our crews and for settling Mars when we have actual, colonists, settlers going to Mars to stay in the hundreds. How are we going to feed them? That's the big challenge right now that we're trying to solve. And so we have, I don't have a slide for it, but we have a contest called the Mars Against Hunger Challenge right now, where we're asking people to work in their own labs to develop ways to grow food at scale in small enclosed environments, but also using new methodologies and new processes that are maybe chemical instead of photosynthesis. So one of the examples we give is you could take methane, the gas methane, and turn it into methanol, which is a liquid. And then you can react the methanol with a yeast, and you can actually make protein powder with that. And you can actually feed that to fish or goats or pigs. And then maybe the people would eat the fish or the goats or the pigs on Mars. That's one way we might do it. So I think that was everything. I think I just have a couple duplicate slides here. Yeah, this is our crew commander in the Arctic working. We have a podcast, Red Planet Live, every couple weeks. So definitely check that out where you find podcasts. And I think that's all for my talk. Thank you very much.
Thank you so much for this amazing lecture that you have shared with us today. Absolutely wonderful. I didn't know that you guys have achieved such beautiful achievements. It's not just a habitat, it's a habitat of creation, I'm gonna call it right now.
Yeah, and we're just one crew. I mean, this was just one crew. We've had 300 crews now, so you can imagine all the different researchers that have come and brought their own projects. I remember we had a crew once of all doctors, all medical doctors, and they were using the 3D printers to create medical type, devices and parts to use out there. That was a really innovative crew. We've had crews that have done a lot of really interesting things with drones. And we actually flew drones as part of my crew here. We were capturing some footage for outreach, but we've had crews that have more systematically flown drones to map the terrain and create really cool videos. And then all the different geological research people have done over the years, people have found all kinds of different types of rocks out there, quartz and and gypsum. There's actually dinosaur fossils out there too. We
Oh
found a
my
di- we
goodness.
we found a dinosaur fossil on the first crew
Yeah.
at MDRS, and we called the paleontology museum about it. And a couple years later, they found a major discovery that's about 2 kilometers north of our station, and that's now been the biggest dinosaur discovery in the last 30 years. And
They
they've
give you
pulled
credit
out.
for it. They give you the credit for it, for helping in the
Uh, I
discovery.
don't. I don't think they're giving us the credit for it,
You must have. Listen.
because we weren't the first people to find dinosaur fossils out there.
Yeah.
But it's just funny that on our first mission we found one. We
I'm
joined the
telling you.
club on our first mission out there. So,
Sincerely,
but
Mr.
yeah,
Burke, what I discover right now, because I am very interested in behavior. I'm studying behavior of animals and also human. And when I see how much you achieved with your crew members, I believe you are not only like developing and adapting to situations to like analog situations of if we're gonna send humans to Mars, but you are creating the perfect type of environment for human creativity. It
that's
must,
true. That's
yeah,
true. It was a very we all were doing very creative things when we were there, and sometimes it was out of necessity. Like you'll have a limited amount of time to do things, so you got to get creative.
absolutely,
So,
absolutely,
but yeah,
yeah.
we were. I mean, I mentioned our journalist Chris Davidson. She was getting people up early in the morning when the light was good to go take pictures with their suits on outside and doing all kinds of creative artistic things. Like she'd project stuff inside the science
Oh.
dome on the walls. Yeah, so there was a lot of creativity on our crew, that was for
So
sure.
this is gonna be my second question actually. Do you
Sure.
think that this creativity is based on the good selection of the of your crew members, or it is actually the environment you guys have created all together that have lead to this beautiful energy that empower each and every one of you to get the
I
best?
think it's kind of both. I mean, it is important who you take with you to Mars. Like it is important to have people that have skills
Mm.
that can contribute to the mission. And everyone that was on that crew had their own set of skills. I showed you all their backgrounds.
Yeah.
We were together a multidisciplinary crew, and that made us. It was like multiplicative. It's like you have one high performing individual, they can do so much, but then you put seven together, and
Oh,
it's like a superhero
jackpot.
team. Yeah. So, and that's how I felt. I felt like we were Mars superheroes. We were. It was almost getting boring at the end because we were so good at doing the EVAs. It
Please
was. It
send
was.
us some energy. Please send us some energy. We need that energy.
Yeah. But no,
Actually,
you're right. Like it's not only the crew selection, but it is the environment, the situation forces you to work together and be creative and
I
solve
believe,
problems together quickly.
yeah, I believe you guys have created a very healthy environment where you can feel super like relaxed and your brain can like reach the maximum of its potentiality, and then you discuss with high quality intellect, and then boom, you have the idea and just go and practice. You have nothing else to do. No drink.
There was a fair amount of that. There was a fair amount of trying new ideas out. That's how the map
Mhm.
experiment came about. That
Yeah.
was just an idea Julian had. Um, but yeah, you're right. It's like, you have a bunch of high performing people get together and magic happens.
I was amazed when you have mentioned about the rover that will be like using just the wind, if I'm not for like mistaken the information, just
Yes,
by
there it
using the
is.
wind. That's amazing. Who is the engineer? She's the lady, right? I forget her name.
Yeah, that's her name is Erin Kennedy. She's from Canada.
Erin. We
Yeah,
are
and
very proud of you. This is amazing. As ecologists, thank you very much from the deepest part of my heart. We are going to make Mars safe and sound because because this is a green energy.
yeah, this is essentially a rover that would be powered by the wind. You see on the right, there's some green sails on each side that she
Oh,
was testing in the wind there. It got very windy in the afternoons, which was perfect for her experiment. I mean, we were getting high winds,
yeah.
and that's she's like, I can't wait to go outside and test out my rover in those winds, and she did, and she was able to collect a lot of data on it and refine the design as we were there, as we did the mission. Yeah,
Just
and I mentioned
just
she just did a TED
wonderful.
talk about this. So
Excellent. Please send her my greetings and tell her that I am very proud of her and I thank her in the name of all humanity for
I
her
sure will.
excellent work. Thank you so much. Let me right now ask our students if they have any questions. Dear all, if you have any questions, please raise the hand symbol so I can see you. And then when you hear your name, you can open your microphone and ask our talented guest speaker the question you have. I saw somebody. Yeah, Sveen, go ahead, dear.
I'm just one. Good morning, Good
Good
morning,
morning.
dear teacher and sir. Today, thank you for the good introduction, sir. And teacher and sir, I just need to ask this question.
Yeah,
I'm
go ahead.
wondering what are the developments that we've had in sending spacecrafts and other things to Mars.
Well, some of the developments we've had, well, we've so far, the people of Earth have sent many different missions to Mars. There's been several rovers that have landed on Mars, and so the biggest accomplishment has been just getting those rovers down on the ground from space. That's a very challenging problem. Some of the NASA rovers, like Curiosity and Perseverance, are very large, about the size of a car. And so getting that all the way from Earth to Mars, but then from Mars orbit down to the surface, have been very difficult engineering challenges that were successfully done. And that's also something that we still need to see developed further for a human mission to Mars, because a human mission, we need to land a much bigger payload, like something like the habitat we just saw. You know, that habitat is a 2-story building. That's going to be much harder to land on Mars than the rovers so far. So new systems still need to be developed to enable that. And it's mostly about protecting the equipment, the spacecraft, from heat as it enters the Mars atmosphere and slows down. It goes from, 20,000 miles an hour down to 0 in 7 minutes. And so there's lots of multiple steps to make that happen. But that type of system is what's the most challenging part of this. But other than that, I mean, people have developed all kinds of different experiments that have been on the rovers that are very innovative, such as the MOXIE experiment that created oxygen on Mars from the air, the carbon dioxide in the air.
Is it clear?
Yes.
Well,
Thank
so
you for the
thank you.
question.
Thank you, teacher and sir.
Thank you very much for the question.
Thank you so much. Actually, I do have a question, Mr. Burke, if you allow me. you have mentioned that these type of analogs, they are open to scientists and high quality researchers. Now we see that the young generations, they are very interested in learning and having this type of practices. Do you think that Mars society in the future gonna like allow young generations to have this experience?
We do have ways for younger people to participate. The VR project is like one way. There are ways to simulate a mission like ours just using VR. We have one of our VR apps is a multi-user one, so you can actually have multiple kids put on headsets at the same time and talk to each other through the headset and draw and communicate and plan things out together. So that this is one way. We also have an engineering competition at the high school level. So ages 13 to 19 can be part of that. And that's a program we have every summer for teams to work together to design a Mars mission and debate other teams about their design. And the kids that have gone through that program all have really learned a lot about Mars and just STEM in general, STEM fields in general. And so that we're trying to expand that program as well to more people.
Excellent, super interesting. Another question, if you allow me. I am excited today. You have mentioned that you are going to start another analog type of habitat in Mongolia, right?
Yes.
For what reason you have selected Mongolia? I know it's amazing. It's very close to me. I love it. But like from your own perspective, as like for research, what was the key components that have lead you to Mongolia?
Well, it's not that we selected Mongolia, it's that people in Mongolia decided to form a Mars Society chapter called Mars V on their own and develop this. And they now have gotten funding from their government. They've actually been upgraded to be the space agency for Mongolia now. And they're working with international partners to do different events in Mongolia. But it's very much led by them, but we're advising them on, how to set up their station, how to run a mission. We offered them a crew slot at MDRS last year, and so they had 5 Mongolian astronauts come and stay at the station in Utah and learn what it was like to be on a mission there. And so, yeah, we're working closely with them to develop that station, but it's being driven by them. And so, same with the Australia one, there's one in French Guiana that we're starting to talk about as well. Down at the European Space Agency's launch site, we want to have more of the folks that are the indigenous French Guyanese be part of space. And so having an educational center at the spaceport that is also a Mars and Moon analog station is what we're working with that team on, with Aline and her other volunteers on.
I am glad to see Mars Society like spreading its wings everywhere in this beautiful planet.
Yes, we have chapters in I think 50 countries now. So we have Aravinda leads our Sri Lanka chapter. We have chapters in India, Bangladesh, Pakistan, China, Singapore, all over South Asia.
I'm gonna search and go.
Yeah. Angela Sui is our China director. Beautiful. And we also work with World Shaper in Shanghai. World Shaper, they have Mars Cell Labs downtown Shanghai.
I will definitely have some opportunity to meet with them. Definitely. I see we have Taruka. Taruka, dear, go ahead. You can open your microphone and ask your question.
Hello, sir. Hello, ma'am. Good morning. I'm Rehan. So thank you for the wonderful lecture today. My question is, when humans first go to Mars, what kind of challenges would they face? Because we see that it's a completely different environment, and even though astronauts would train in areas like, in simulations like this, conditions would be the flip side and completely different. So, what challenges do we expect?
Yeah, that's a great question. There's going to be a lot of challenges for the first crew. They're going to need to stay alive, number one, throughout the mission. It's about a 3-year mission to go all the way to Mars and back, because you don't just turn around when you get to Mars. You're going to spend about a year on the surface exploring and hopefully making scientific discoveries while you're waiting for your window to open up to come home. So it's about a 3-year mission with chemical propulsion, which is what we have with Starship. And so just making sure that the crew stays safe and is able to function and is able to navigate any challenges that they come up with, whether their equipment is working or not, whether their power system is working. I mean, some of the challenges that we have in Utah are very similar. We're constantly struggling to make sure that our power system is optimal and is charging its batteries.
Yeah.
The rovers have enough charge to go out as far as they can and come back. That everyone is comfortable, at night. It's not super cold upstairs at night in the desert, or super hot during the day for people. Like the climate controls inside the station are working correctly. And then just all the experiments that usually people are doing, they require gear to do those experiments and equipment to analyze samples and things like that. So just making sure everything works out there in a harsh environment is one challenge that you would also have on Mars. And then just people getting along. Like when you have 6 or 7 people that work well together in, a shirt sleeve conference room environment, but then you put them out in the Utah desert, maybe they don't work exactly the same together.
You can build
It changes.
nations. If you by just your crew, I trust me, you can build a nation of intelligent people.
Yeah, if you have them working well together, they can accomplish a lot for sure. But
Very
those
nice.
are the big challenges. It's not just the environment; it's people working well together. That's one of the things that we try to
Yeah.
research right now. That's one of the things we can research is the
High
human
quality
factors.
human, right?
Mhm.
High quality of people. Well,
And people
Rihan,
working well together, communicating together well. Yeah.
I have actually, you have mentioned something very interesting, Mr. Burke. A human right now in our society, I may say, when we work together at certain point in time, I don't know when exactly, but it happened always, we get jealous of the success of any of our crew members. Why that? And why it not happening in your habitat? What is wrong with the society today?
Well, yeah, no, I think we were so busy. I think we were very focused as a crew, and I think not everyone out in the real world is as focused as we were.
Hmm.
So that's one thing. I think if
Yeah.
you have passion for something and you work hard at it, that solves a lot of other problems that people may have.
You focus on the goal, not in your ego, I believe.
Right.
Yeah.
Yeah,
And the success
exactly.
of your team members, it's your own success.
Yeah, people have their own prejudices and biases that they can either bring or leave behind when they're on a crew.
Imagine if we will send our like some of our humans right now to Mars with all the wars that are going on. It's oh no.
I don't
We're
even
going-
like to think about, like, people ask me when we settle Mars and we have like multiple settlements, are they ever going to go to war with each other? I hate that idea. I don't think we should. I think war should be illegal. I think we should outlaw war.
I agree. I agree.
But certainly in space, like there's nothing good that would come from people trying to hurt each other in space. And it would be so easy to like kill somebody. Like all you have to do is put a hole in their spacesuit.
To be honest, honestly speaking, war have its own economical type of thing.
Yeah.
So as far as we are like, because in Mars we're gonna have time to build the societies, to build the economy. So it's gonna take some centuries to arrive to the situation.
I hope not. I hope not. I hope that what we can do is we can send the best of humanity to Mars, and they can level up us as a society, and show people on Earth how to behave, how to work together.
I agree with you. For me, I believe that a war, if you have a conflict, two countries have conflict, they can just settle an area for one to fight or something like that, and handle the situation. Do not kill others, please. This is how I think about the situation. Why we are losing time? For me, war is losing time, losing potential of human, wasting time.
It definitely is not a positive thing. It gets in the way of science.
Yes, those people who pass away, they was babies, and then they grow. We have spent a lot of money on them. We teach them, and then we kill them by our own hands. Why?
No, it's not a good system. No,
it's not smart at all.
No.
Well, we have to think about this, I believe. Let me ask right now, Tilani. Go ahead, dear. You can open your microphone and ask your question.
Good morning, Madam and Sir.
Good morning.
I'm Sasmik Caldera. I have a question. When humans land on Mars surface, how they are going to survive from the radiation and ultraviolet rays, because there is no ozone layer to protect the humans from those rays coming from the sun?
Yeah, that's a great question. So on Mars, radiation is a risk because there's no magnetic field on Mars. Here on the Earth, we're shielded from the sun's radiation by our magnetic field. And when there's a solar flare from the sun, we're usually protected. But when you're out in space or you're on the surface of Mars, you're not. And so you have to pay attention to the sun, whether there's a solar flare heading your way. But there's some innate risk of radiation just traveling in space as well. Now, it's not enough to not go at all to Mars. Like, there's ways to mitigate the exposures you get for radiation, but it is a concern. And so, most astronauts do have a higher risk of getting cancer as a result of their space travel. That's part of it. We estimate it's like a couple percent, for a Mars trip, but that is an area of research that needs to have more done in it. Ways to mitigate: you could shield the crew on their way to Mars. In the spacecraft, they're using different ways. You can shield it just with having lots of material between you and the outside. Even like water could be a good shield, like have a couple meters of water between you and the outside of the spacecraft. That would shield you from radiation, from solar flares, not cosmic rays. Cosmic rays you can't really do anything about, but solar flares you can have a shelter, and people get in the shelter to stay safe. And then on the surface of Mars, I think when you get into having settlements and people there permanently, a lot of those are going to be underground, because you're going to have natural radiation shielding from being underground. Being in like a cave or a lava tube that has several feet of rock above you is going to shield you from radiation. So a lot of the concepts we see for permanent bases, there's usually, and I showed you one today, there's usually like a lot of underground area that people are spending time in, and just they're only on the surface for short periods of time.
Well, thank you so much for this explanation. And I believe Rehan also still have one other question, if you have time, Mr. Burk.
Of course.
Thank you. Go ahead.
Hi, sir. Thank you again. So I have two more questions, sir. Second one is, sir, have you seen the Martian movie?
Yes,
Um,
I have.
so basically, what happens is one man is able to survive for, I believe, a couple of years. If this happens in real life when humans go to Mars, will they literally be available to survive? Is it possible?
I think, well, first of all, that's a movie and a kind of a fantasy story. I don't think it's going to happen exactly like that when we go to Mars, but it's a very entertaining movie. It's one of my favorites. Um, but I think when we have crews that go to Mars, we are going to send a lot of supplies with them in the cases where they need to stay longer. So we'll pre-stage a lot of gear and supplies and multiple redundancies, multiple backups for crews. So hopefully there'll never be a situation like that where someone is stranded on Mars and has to grow their own food, grow potatoes and things like that. But there were a lot of realistic elements to that movie. I mean, that was a pretty realistic movie overall, science-wise. We love that movie at the Mars Society because it resulted in people being more interested in this field and seeing that it's not science fiction, that it's actually near future engineering that we're doing. So I think it's overall it was a good movie, pretty accurate, but I think in a real situation like that, there'd be a lot of backup supplies and backup escape plans too, like more than just one Earth return vehicle, for example.
Thank you, sir.
Of course.
Final question, sir, is I was going through the Mars Society website just a few hours ago, and I saw that we could volunteer in the IT field as well. Will it be possible for you to give more information on this?
Yeah, we have lots of different volunteer opportunities. We have lots of volunteer teams that work on various projects and programs. For the station in Utah, we often have volunteer work crews that come and work on the station. The next one of those will be in May and June of next year. But yeah, absolutely. Anyone can volunteer for the Mars Society and get involved with what we're doing.
Okay. Thank you so much, sir.
Thank you.
Thank you very much. And actually, right now, I'm going to invite our CEO to give some of his comments before ending this beautiful session.
Thank you very much, Joda. And thank you very much, dear James, to accepting our invitation again. I'd like the Mars Society, MDRS, Mars Technology Institute, are doing a tremendous work of providing Mars outreach and advocacy in this planet Earth. It's going to be really supportive to even the researchers, even the scientists to get much more understanding about the future Mars. So again and again, thanks for the James, and I'm also here for supporting Mars Society, and in the near future, I'm interested to send in our Mars artificial regolith to the MDRS, and I believe like in the future you guys can working on it. And thanks for again.
Thank you so much. I really appreciate it. It's been an honor to talk to you all today, and I wish you all success in the future, and I hope you keep being interested in Mars.
Thank you so much. The honor is ours to have you. For oh my goodness, we are sincerely very, very, very honored to have you and to discover all this amazing creativity that you and your crew have achieved. You are not even sharing your creativity, you are also impacting us in a positive way. This is good energy here, sharing it with us, with the world, and empowering us as well. And we hope to make you proud as well in the future.
Oh, I'm sure you will. I'm sure you all will. Thank you so much, and please stay in touch.
And Merry Christmas, by the way.
Thank you very much. Happy holidays to everyone.
Thank you so much. See you soon.